get started, we're going to build this prototype shield, or shield that's going to go on top of our Arduino, and it just plugs in like that. It sort of lines up and plugs in. That will hold the real-time clock module and a couple of connectors for our various sensors and display units. So to do this part, you're going to need a Protoshield. They kind of look like this. Real-time clock module, and this is one that doesn't use a rechargeable battery. We're going to need some connectors. These will be used and attached to the Protoshield so that we can run cables to our sensors and display units. Some header pins. These are going to be attached to the real-time clock unit so that we can mount those on there and then mount that directly on top of the Protoshield. And some various soldering iron, wire strippers, and a third hand. You also need some wires, some extra wire just to connect things up on the back end of the Protoshield. Solder, of course. And if you don't want to go through all the trouble of doing a lot of these things, you can use just a little breadboard, sticky breadboard unit on there, and just plug things in like you normally do without all the soldering if it's too complicated. Or really, this can just be mounted beside your Arduino in the final controller, which is kind of what I have right now, but then you risk the chance of the wires getting knocked out, etc. This is just more of a more stable, permanent setup that we're going for here. Okay, so the first thing we're going to do is solder the header pins to the real-time clock module, and you can see in the final version here, the reason I have the pins, and you can kind of see through here, is that the pins allow the real-time clock module to be soldered directly to the breadboard. It's a little hard to see in there. If I could rotate it around, we could see through there. So I have header pins here and here, and you can see them poking up through there. This one on this side, the way the holes work on the proto board, I could only use 3 or 4 here, 4, but these aren't the side that have the electrical connection. I just have those for stability. These ones over here are the ones we're going to be connecting to the pin outs. So really not much to this process other than breaking off the correct number header pins, putting them, I don't have the correct number here. What do I want? So say on this side I want 5. Broke off 5, and then you're going to put them, just going to insert them in, and a little dab of solder there, and they'll be ready to plug in. Now of course I've got it battery side up on the finished product because I want to be able to change the battery. And you can see where I've soldered. These are the ones here that are not used. These are the ones that we're going to be connecting soldering wires to and connecting to the power strips here and the various pins that we need to on either side. Once you've got your real-time clock module soldered to your prototype board, you're going to go ahead and install these little receiver pins here that are going to allow us to plug our cables into, that are going to go to our sensors and display units. They, if you look on the bottom here, you can see that there are these 3 holes in a row are connected with the silver strips. So I've made sure that the pins are in the first one so I can put connectors into the other ones down here. Same with on the other side. So if you flip it over, you can see that these are sitting on in the first row of holes, and now those other holes are open so I can connect wires to, so I can go to the jumpers, or I can jump to the various pins I need to. The next step is to wire up your real-time controller, and if you look at the little board we have here, you actually only need to wire up the first 4 connections on it. We have ground, VCC, the plus 5 volts, and then these 2 pins here are going to go to pin 0, analog 0 and analog 1. And so what I've done is on the back side I've connected, just used wire to connect to some empty holes on the board for the A0 and A1, and then for the ground and the positive I have them attached to these 2 power rails here. And then on the other side for the A0 and A1 I just soldered in 2 jumpers and have them going into the A0 and A1 ports. For our next step, we're going to wire up some connectors to go from our board, these posts we put on the board, to our various sensors. I have some 18-inch wire here, and we're going to use these to make female-to-female connectors with these little units here. Female-to-female connectors to go to our infrared remote receiver, our LCD display unit, and also to the relay unit that we're going to use to control the sockets. For the when we actually get the temperature and humidity sensor, you're going to want to use a much longer cable, like this 10-foot section of cable, and you could use ribbon cable, but I just happen to have Cat 5. I'm not showing that one here because I've already done that one. But as I said, for the temperature and humidity sensor, since that goes outside the box, you may want a decent length of cable to attach to it. You can see I've stripped down this piece of wire and left about 1 inch off the end, and maybe about a 1/3 of an inch stripped off. We're going to be going through the very finicky process of using a pair of pliers to crimp these little tiny connectors onto the end of each of these wires, and then inserting the completed connectors into here. Want to make sure that you have pin 1 on here and pin 1 on here the same color. So I've just got them both set up on the third hand here, because I want to make sure that if I put this one on this way, that the same thing is going to happen over here on the other side, that the same pins are connected. Now that I've got my connectors attached to the end of my wires, I'm going to go ahead and push them into the little receiver units here, and you can see there's a small little notch at the bottom. That's where the sort of springy connector piece goes in. So I'm going to do green, light green, hang on, green, light green, blue, light blue, and I'm going to work those in. And then what I can do is I just use a little small screwdriver to kind of push them the rest of the way in there. So I've completed attaching the ends onto our wire, and now we have the ability to attach these things to the plugs we've added up to the board, just like that, nice and neat. And then the other end is going to get connected to our relay unit, and we have some extra cable here that we can fold up or tie up inside the box when we're done. Okay, I've attached the real-time clock, and we have done some connections here on the back. You can see that the prototype board comes with a couple of power rails, so I've attached those to the ground and the VCC for the real-time clock module. And then these other 2 wires here, I have them connected over here, and on the other side I have those soldered to these 2 wires, which are coming into the analog 4 and analog 5 ports. And this is where both the real-time clock and the LCD module are both going to come into the exact same 2 analog ports, and the signal that's going to go out on there is going to be able to communicate with them both. Now that we have our cables made, we're going to hook in our components to the shield. This is the 16 by 2 display unit with a little backpack on it. It's going to go into the 4-pin connector we made. This is the DHT11 temperature sensor. It's got 3 pins. It'll go into the 3-pin connector. This is the little infrared remote receiver. It's going to also go into a 3-pin connector, and those will connect into the board here where we have our sockets that we've set up, and then we'll figure out which pins have to be connected to the power rails and which ones we need to attach a jumper to so we can attach to the various digital pins, etc. Now that all of our wires are created, what I've done is I've attached the wires to the board here. So let me zoom in a little bit here. You can see that I've got there's 2 of them that are 3 sockets and 2 3 wires, 1 4 wire, and a 6 wire. And they're connected into the board like that. They're not connected to anything yet, but we're going to do that next. And each of the wires is connected to a component. So here we have the this is the little infrared remote receiver unit. We have our 16 by 2 display unit that has a backpack on it. We have on the very long cable our DHT11 temperature and humidity sensor. That's about a 10-foot cable that's on. And then on the 6 wire we have the relay module that we're going to use to control the electrical sockets. So what we're going to do now is, now that those are all connected, look at the colors of the wire and what they're connected to, and finish connecting those into the appropriate we'll connect the appropriate power pins to the, you can see there's 2 power rails inside there. Those 2 power rails, so we'll connect the ground and the plus 5 volts for each of these 4 connectors to those power rails, and we'll attach jumpers like we did here with a little bit of solder so that we can connect into the required digital ports. Okay, I've gone ahead and finished hooking everything up, and I've attached it to the shield to the Arduino underneath. I've attached all the sensors with the various cables that we've built, and I've plugged in a power source, in this case just the USB from the computer. And I know that that's do a little zoom in. I'm going to have a wiring diagram on the video because obviously there's lots of wiring going on in here. But you can see it's now stacked on top of the Arduino underneath. And I have all of the items are connected. You can see our display unit that's giving us the current temperature and humidity in the room. This is the relay unit where this relay is lights. I think it's lights, humidity, heat, and ventilation. And right now lights, humidity, and heat are on and ventilation is off. And if you look at the temperature is 15 degrees Celsius in the room right now, 20 degrees humidity, and I've set the default, I think, is 22 degrees and 60% humidity, so it makes sense that those things are on. We have our little DHT11 sensor, and as well our little our IR sensor. So what we should be able to do is, using the remote, I should be able to adjust the time in minutes, temperature setting, humidity, light on time, light off time, ventilation frequency, and back here. So the sketch will be in the description below. You can download and take a look at it and install it. Okay, what I've done is I've marked out where I want the sockets to go on the outside of our box, and gone ahead and cut a hole, cut holes in it. I used this hole saw, which, as you can see, it ground the tips right off the blade and pretty much destroyed it. So I'm not exactly sure what the best way to do it, but that's maybe a higher quality hole saw bit is probably what you'd use. But and then I used a file just to wear down the edges. Anyways, I need a way to pass the electrical cable through. What I've purchased are these Wiremold surface mount electrical boxes, and they're going to go on top here like this, and they will attach right to the surface of the box. We'll have to drill some holes in here and use some screws, but it comes with a plate that you can use to attach directly to the surface. So we're going to go ahead and do that, and then we'll get to wiring up the sockets. Okay, so I've attached the plates, and you can see I used actually these drill point screws. I just drilled a little pilot hole and used a little hex nut driver to drive those in 4 spots, and then this plastic piece goes over top to that. The base plates will get screwed to the surface, and then this plastic piece goes over top. And I've already put in the 2 sockets here. This is a little short because in my previous project I had to trim it. I'm going to replace this plate shortly with a full-size one. And the electrical is gone through, and we are going to hook that up shortly. This is an example of what's wired behind this plate here. I have the 2 sockets. I have the common on both are tied together, coming from one strand. The black hot wires are separate, and the grounds are tied together. So it just means we have fewer wires coming through the back end to deal with. There's only 4 to deal with. Okay, things are starting to take shape. What I've done is attached the relay unit, the Arduino, and a terminal block to a piece of wood. And on the box itself, we're starting to see the wiring take place. I've drilled a hole and placed one of these little conduit connectors in there, and I've got 3 things going in. This is the power cable, so that's going through to the other side. The yellow one is actually the USB cable that we use to power the Arduino inside, and as well attach it to the computer for updates, etc. And the third one is this long network cable, and somewhere here on the end of it is the DHT11. So that's going to go into our greenhouse. And those 3 are going to be run through here, and they're secured with a few screws inside. And the other thing I've done is I've gone and attached, so there's our USB, there's our plug-in for our DHT11, and then, as I said, I've gone ahead and attached some terminal connectors on the wires so that I can put them onto the block easier. Okay, it's all wired up here. We're almost done. I've run, actually, this is the display unit adapter piece. These little Wiremold things have little punch outs at the bottom for connecting side to side, so I just punched that out and I ran the wire through to the other side. Oh, you can see it here, so sorry, I've taken that off. You can see that I've just sort of run it behind the electrical socket. Also in there, you can see in the bottom corner here, I've drilled a little hole here and attached the infrared sensor with some hot glue. So those are those two bits, and the rest of it is as per the design. It's all wired up. I have actually set all of these up as lights and humidifier and heater. I just because I'm keeping the fans on all the time, but the code is still there to support 4 relays. So let's go ahead and pack this up and see how it works. Okay, so we're up and running. and we are monitoring the temperature and humidity of this greenhouse over here. This is the one, I've got two greenhouses. One on the right is a really hot, humid climate for starting seedlings, and this bigger one over here is for the more mature plants. So I've got in here, they get kind of big. And you can see there's the DHT11 that's monitoring temperature and humidity, which right now is 19 degrees and 18% humidity. I'm going to be hooking up a bubbler to get some more humidity in here because it's pretty low.